right, we proved the argument on our screen valid in the previous lecture. That is, we constructed a truth table that represents all possibilities, and that truth table indicates that it is not included as a possibility for the conclusion to be false when all the premises are true. Therefore, the argument's valid. Now take a look at this argument. If it is snowing, then the mail will be late. The mail will be late. Therefore, it is snowing. And you'll notice this is a very similar argument to the first one. The first premises are identical, but the second premises are different, and the conclusions are different. Now we can test this argument using a truth table by using the same strategy that we used to test the first argument. So the first thing we do is we identify the simple statements that make up the argument, and we can see that for our second argument, it's the same two simple statements that make up this argument as did the first. It is snowing, the mail will be late. So what we do is we symbolize this argument on a single line using letters and operators, and we make sure that we separate the premise statements from one another with a single slash, and we separate the conclusion from the final premise using a double slash. And now we can use L equals 2 to the n to start constructing our truth value, the truth values for our individual letters, and ultimately for the operator. When we do so, this is the combination that we get. Okay, so we've got our truth table, and now what we want to know is this. There are 4 possible ways reality could be structured at any moment, and each of those ways is represented by these 4 lines. Okay, these 4 lines are all particular moments in time, and what we're most concerned with are the 2 lines where the conclusion statement is false. We're not concerned with lines where the conclusion statement is true. What we want to know is this. On those lines where the conclusion is false, are all of the premises true on either one of those lines? So we look at line 4, and we can see here that on line 4, the first premise is true and the second premise is false. But when we look at line number 3, the conclusion is false and all of the premises are true. By definition, this is an invalid argument, okay? And when we determine that an argument is invalid using a truth table, we're always going to indicate what line or lines prove the argument invalid. So we're going to say invalid line 3. On line 3, all the premises are true and the conclusion is false. Now you can go back in and you can start analyzing what scenario number 3 looks like. How could it be possible for the conclusion statement to be false when all the premises are true? Well, let's just assume that the mail is going to be late, okay? And we have that indicated as true here. So the mail will be late is a true statement in our first premise and in our second premise. But maybe the mail is going to be late because the mail carrier got bit by a dog or got a flat tire in the mail truck. So even though it's not true that it's snowing, the mail's still going to be late, but it's going to be late for some other reason. So it doesn't follow from if it is snowing, the mail will be late, and the mail being late, that it's snowing necessarily. Okay? And this truth table proves that this is an unreliable, invalid argument.